Hey guys, it's Mr. Keeler. This is obviously not how I thought this trimester was going to go. This class will look totally different from what I normally do in astronomy and meteorology, but we are going to make the best of it and we're going to learn some stuff regardless. So you're going to start out each week with some outdoor observations, because really that's what science is all about, is making observations and then trying to make sense of why things look like they do, why they act like they do. For example, I have clouds in the sky behind me. They don't all look the same. Why? Why is one bigger than the other one? Why is one a little higher than the other one? Why does one look really puffy and one just cover the entire sky? Why does one rain and one not rain? So what we're gonna do is we're gonna try and observe some clouds through the week. And through these videos, I'm gonna attempt to explain to you why they look different and what that tells you about the weather. The goal of this is to really give you some tools so that you could just look outside every day and know something about the weather that's here now and the weather that is coming soon.
The first major way we get clouds is in low pressure centers. So let's take a second and make sure we understand what high and low pressure centers actually look like. So as you can see on this sheet, the area over here has lots of air molecules, which are these dots. So we're going to label that as an area where the air is more dense. Now over here you can see there's clearly less dots. So we're going to go ahead and label this area as less dense. Now, I don't know what you remember from earth science and convection down in the Earth's mantle, but areas that are more dense, the molecules are closer, and as a result, they will sink. And any area that's less dense, where the molecules are more spread out, it will rise. So what we have here is a situation where a high pressure center, where there's more air molecules, and a low pressure center, where there's less air molecules, actually is setting up a big convection current in the air. Now, since water vapor is part of the air, in this area, the water vapor is going down. Over here, the water vapor is going up. Now, when water vapor goes up, it starts to get cold. And when it gets colder, the water vapor will condense into clouds. So that's a very simple reason why low pressure areas give us clouds. In high pressure area, since it's more dense and sinking, the water vapor is going down, which means it's not getting colder, so it's not condensing. So instead, we tend to get clear skies in high pressure areas. The other main way that we get clouds is along fronts. So as you can see on this sheet of paper, the two main fronts we have here in Michigan tend to be cold fronts and warm fronts. And so we're going to start by looking at this cold front and how it makes clouds. So if you remember, a front is when one air mass is pushing into another one. So you can see I've got cold air shoving up against the warm air. Now, in a cold front, the slope between these air masses is really steep, thus the word steep. Anyway, the arrow is showing you that the air is going up extremely fast. Now, when air rises fast, it's going to cool off and condense, and since it's going up fast, the cloud is going to be forced to grow upward, which results in this puffy shape. Now, something else I want you to notice is all the moisture gets contained in a very narrow band right here. So, along my cold front, the air's getting forced up fast, so the moisture condenses into a puffy, narrow band of clouds. Now, if enough moisture goes up and you get rain, all the moisture is really close together. So these water droplets hit and get really large, and when they fall in a really narrow band, but the drops are huge, so they fall really fast. So you get this intense rain right here, which we normally would call a thunderstorm, which if you remember from day one, which is why we get our thunderstorms along our cold fronts. Now, compare that to a warm front. Now, in a warm front, it's also warm air meeting cold air, but this time the warm air is coming up behind it. And you'll notice it has a much gradual slope. That was a terrible sentence. A much more gradual slope. Since it's gradual, the air is going to go up slowly. And when air goes up slowly, compared to up here, it's going to have time to spread out. And you're going to get these clouds that seem to cover, so this is you down here, looking good. It's going to cover the entire sky in layers, which are stratus type clouds. And what that does and what that means for us is if there's enough moisture in the air to give us clouds and give us rain, it's over a really wide area. Yes, I just struggled to spell the word wide, but anyway, over a wide area, the rain is going to be spread out. So instead of having intense heavy rain like a thunderstorm, you get very light rain because it's all spread out over this wide slope. And that is the types of clouds and the type of rain you get at cold fronts and warm fronts. Okay, this one's gonna be really short and sweet. Basically, as air rises, it forms clouds, right? Now, the rate at which it rises is going to determine the shape of the cloud. So if you were listening during the last video, I already covered this, but I'm going to hit it one more time. This picture has some puffy cumulus type clouds. That's simply because the air is rising fast. If it's more spread out and it covers most of the sky, it's a layered stratus cloud, and that's because the air is rising really slow. So in a nutshell, if the air goes up fast, you get puffy clouds. If it rises slow, you get clouds that form a layer. The last thing I'd like you to learn about clouds is how the size and the height of the clouds is determined. And as you can see on my paper, it all comes down to whether the air has low humidity or high humidity. So we're going to start with low humidity. So let's assume we have some air that's not very humid, and let's assume it starts to rise. Whether it's low pressure or a front or whatever, it doesn't really matter. The air is rising. Since there's not much moisture in the air, can you guess how big the cloud is going to be? Exactly, little cloud. Now, all the little clouds are going to form way up high in the atmosphere. Okay, so what you can tell when you look outside is if you see small clouds, they're going to be way up high in the atmosphere, and that tells you the air is not terribly humid. The opposite is also true. If I have very humid air, like over here, and it starts rising, I'm going to get clouds that are a whole lot bigger. Why are they a whole lot bigger? Because there is lots of moisture available. Now, those big heavy clouds always form closer to the ground. So if it's going to rain, that means there's excessively high amounts of moisture, so you know those clouds are going to be really, really low and really, really big. So as you're looking outside, if you see really big, thick clouds and they're close to the ground, you know there's a good chance for rain. If you see really small clouds way up high, you know the air is not that humid, the chance of rain is slim to none.
It's important to know that the weather in Michigan always comes from the west to the east. So as I look east, which is behind me right now, you'll see not many clouds, and they tend to be on the small side. Now watch what happens as I spin around and show you what's to the west. If you look in the sky to the west, what you notice is the clouds tend to be bigger, and there appears to be a lot more of them. That tells us the weather that's coming has more humidity, and since they're a little bit puffier, the air tends to be rising a little bit faster.